Okay, so first of all, when I look at this, just doing a little quick bell work. This is going to be a short video on just a couple completing the squares. At the end of this chapter, you'll see ellipses and then hyperbolas, and we'll take like 2 days on each one of those. Then we're going to have a day of just what is it, and then complete the square, and it's like a review section, but it's a complete the square day with all of them jumbled together. And you're going to have to know before you complete the square, what am I dealing with? So we only have two things right now. So it's a 50-50 question. What is this? Is this a parabola or is this a circle? 3, 2, 1, go. Why did everyone say parabola? That's nice. One or two people said circle last hour. Did someone raise their hand and give me like a reason? Go ahead. There isn't an x squared. And that's where a parabola sticks out like a sore thumb. You don't know this yet, but when we get to ellipses and hyperbolas, they also have two squared terms. Both the x and the y are squared. But there are minor differences between those and a circle. So that's why now we have circle and then ellipses and then hyperbolas. They have a ton of similarities in their equations. Parabola is the only one where there's only one squared. So right off the bat, we should know that this is a parabola. And then as we do ellipses and hyperbolas, try to analyze the differences in those equations, but that's not yet. So, and then what is this parabola going to be then? We should know that it's the y that I need by itself equals the x by itself on the other side. Y minus k, x minus h. I just wanted to make sure I have my h's and k's in the right spot. So now I know this is what I'm trying to accomplish. And then this is another thing that parabolas stick out like a sore thumb. They're the only one where the y squared is on one side and the x is on the other. Circles, we had those all on the same side when we're completing the square. So with that being said, I need the y's on one side. Ooh, I'm leaving that space there. And I need to subtract 8x and subtract 14. I need it on the other side to start getting this format down, to start getting this format matching here. First of all, whatever I do to one side, say it. Okay, equations are like a balance. A balance is a science thing. I was shocked how many people don't raise their hand last hour. You guys ever deal with scale? And then it's even, then you put some weights on this side, and then the scale goes like this, and then that means you have to put a counterweight on the other side to get it balanced again. Anyone ever seen that scale before? All right. I know in grade school we would work with those a lot. It's kind of fun in science class. So here's the balance. I'm going to add a number here, so I better add a number here. This is the biggest thing missed when people complete the square. They're all proud of themselves on the left side that they accomplished the task, but then they violate the whatever I do to one side, say it, do to the other. Okay, and then what is that number? Well, when I say complete the square, you say take, come on, half the middle term, and then what? Square it. So what's half of negative 10? What's half of negative 10? 3, 2, 1, go. And then what's negative 5 squared? If you say negative, get out. What's negative 5 squared? 25. And then you're going to want to write this number down here because in the future for completing the square, you're going to have fractions in here. Absolutely. What? I'm going to factor a fraction situation in a polynomial. You actually are. All right, it is going to happen. Because then when I factor this, and I'm done with this, good FOILers, anyone? Good factors. I'm done with showing FOIL. I'm done. Okay, if you don't know how to FOIL at this point, you're doomed. I'm quitting on you. We have FOILs in August, September, October, and November. 4 months. All right? And at this point, if you don't know how to FOIL, it is on your shoulders 100%. Nobody else's. All right? Anyway, so this factors to be y. Okay, what multiplies to 25 and adds to negative 10? What is that answer? It's right before you square. This is the whole reason why we did this. So this is y minus 5 times y minus 5, which is y minus 5 squared. If you wrote those next to each other and FOILed, then you would get y squared minus 10y plus 25. That's what I'm done with. I'm tired of it. Okay, we can only go through things so many times before it actually sinks in with some of you. All right, done. Very frustrating. Okay, and now I take that -8 and factor it out because that's what the format looks like. 4p x minus h. I don't know what the h is. I got to factor out that -8. So what does 11 become? It's actually very simple. Sorry, 11/8. And why is it negative? Because I pulled a negative out. Why is it negative? Because good distributors are good factors. If I throw that -8 back in, -8 times negative is positive. The 8's cancel, I end up with 11. So that's why that's 11/8 there, minus. Okay, which way does this go? Right, left, up, or down? 3, 2, 1, go. Oh my gosh. That sounded like a majority of downs. That's a lefter. So be careful on that. Otherwise, you're doomed and destroyed. Okay, so this is a vertex. I almost said center. Remember, it's x comma y, so don't mess that up. And by the way, 11/8 is 1 3/8, so it ain't no thing. Just want to know kind of where it is in the coordinate plane. So I guess I'll go over here and then put my information to the right. So 1, 2, 3, 4, -1. 1 3/8 is approximately there. 1, 2, 3, 4, 5. So 1 3/8 approximately right around there. So when you have a decimal or a fractional vertex, just ballpark it. Not a big deal. All right, and then since I know it goes left, by the way, what's P? 3, 2, 1, go. Oh no, let's try that again. What's P? 3, 2, 1, go. -2. 4p equals -8, so p equals technically -2. I didn't do that internet thing I was warning you about. I didn't get around to it. I'm going to be honest. And then I forgot that I said that yesterday when I walked in this morning. I said, forget it. I'll just do a couple complete the squares and we should be fine. All right. So the focus is then 2 to the left. Now watch how I do this. 11/8. And I have to go 2 left. And then I can bring Lexi Samuelis in now. Hey, Lexi, how do I take 11/8 minus 2? And that's true, a 6th grader. Actually, a 4th grader should know how to do this. And I say these things not to rip on you. I say these things because we got to make math simple and understand that we access some grade school stuff in this class. And I yell at my seniors because they cannot do fractions, the majority of them. So what's 11 minus 16? -5/8. Comma 5. And then when I graph that, a ballpark is close to -1. So ballpark it, it's like right around there. That's why it has to be over there because this goes left. And that's why I asked you that before. If you said down, everything's wrong then after this, and that would be bad. And then what's the directrix? I have to go to right of 11/8. So that's adding 16/8. So the directrix is not just 27/8. It is x equals 27/8 unless you want to get marked wrong. All right, vertical lines are x equals. All right, and then this is 3 3/8, I believe. 27/8, 3 3/8. So I can ballpark it 1, 2, 3 3/8, approximately right around there. Good enough, good enough. All right, and then one more thing, even though this is a demisol, 8. So I'm going to go 4 up, 1, 2, 3, 4 to give me those little focal width points. 1, 2, 3, 4. That is a width of 8. Width of 8 above and below the focus. And that gives me some more of a picture there. One more thing. I'm going to ask you to do this today. And I guess I have space over here. I've mentioned it, but I think I have not formed. What the heck was that? I love this pen. I love this computer. Symmetry. The axis of symmetry is just this simple little line that cuts the graph in half. By the way, what is that? X equals or Y equals? 3, 2, 1, go. Y equals. There you are. Good. And it's Y equals the Y coordinate, 5. Not a big deal. Yes, the axis of symmetry is always perpendicular to the directrix, and that should make sense there. So just adding that little component there. Why is that called an axis of symmetry? It's very simple. There's a mirror image about this on both sides of that line. Okay? All right, and then obviously you probably know the answer to this. What is this, a circle or parabola? 3, 2, 1, go. Whoa! I heard someone say parabola. Why is it a circle? Why is it a circle? There's what? 2 squares. All right, and then ellipses and hyperbolas will also have 2 squares, but they'll have minor differences. There will be minor differences in the equation. All right, so, okay, I know it's a circle. So I should have this format. X minus h squared plus y minus k squared. This is your file. This is the file you pull out of your brain. Remember I told you your brain is like a computer. All right, and you do file things. They're in there. All right, so there's your circle file. So, okay, that means I want to group the x's together. I have a minus 6x. And then I want to group the y's together. Ooh, what is he putting this big space for? Well, what am I going to have to do? What am I going to have to do? 3, 2, 1, go. What do you think? Complete the square. This is the first time I'm doing this, and this is why I made this decision. Because actually on your worksheet today, we do have a complete the square like this. Yesterday, I wanted to go slow, and in your homework, it was slow. I think there was only one complete the square, and it was only one of the terms we had to complete the square. Well, in circles, ellipses, and hyperbolas, you're going to have to complete the square twice. Because look at this. I got to get this in factored form, but also this in factored form. So I have to complete the square on the x's and the y's. Whatever I do to one side, say it. So I'm going to complete the square over here. Sorry, I didn't finish. You do want to subtract that 11 because it has nothing to do with the x's and the y's. That's part of the radius squared, the r squared. So subtract 11. And whatever I do to one side, I do to the other. I got to do this twice. And there's what I mean about completing the square 5 days. Wrong. Now 6 days for sure. And here's our little stretch out now. Our next concept, expanding your universe a little bit. All right? And it's okay. Whatever I do to one side, say it. See, I can do whatever I want. So I have to add 2 numbers to this side. It's okay. I'll add those same 2 numbers to the other side to keep the balance. I can do whatever I want in equations as long as I do it to both sides. When I say complete the square, you say take, come on, half the middle term and then what? Your friend's not talking. All right. Take half the middle term. No excuses. You were here for this. And then square it. What's negative 3 squared? 3, 2, 1, go. If you say negative 9, get out. Go sit out in the rain. Ah! He's so mean. I'm so sick of these silly mistakes, and they got to stop. All right? Squaring negatives and getting negatives. What is going on? What's half of 8? 3, 2, 1, go. 4. What's 4 squared? And then here I did it. I'm all proud of myself. And I'm moving on. Whatever you do to one side, say it. This happens all the time, and it is. I think you're all proud. Hey, I'm getting this completing the square. I put the numbers in. I feel good. And then you didn't do it to the other side because you got focused on one side, not the other. All right? And then what's this factored? What multiplies a 9 and adds to negative 6? 3, 2, 1. What's the answer? Did you see me focus on that? This is also when we get into tougher factoring, when we have fractions, you're really going to want to focus on that number before the squaring, because that is the factoring number. X minus 3 times x minus 3, which is x minus 3 squared. What multiplies a 16 and adds to 8? 3, 2, 1. What's the answer? 4. All right? That's the whole point of this. Hope you really saw that I focused on that pretty much. All right, so plus y plus 4 times y plus 4, which is y plus 4 squared. And then this is negative 2, so this is just 14 over here. So what do we have for a center? We have 3, comma, -4. And then what do we have for a radius? We have the square root of 14, which I think last hour, can someone hit that in their calculator that has a calculator out? You should always have your calculator out and ready. 3.74. Okay, so this is all you do about that. Super fast in graphing this. I think you can get it, but let's just make sure. Go to 5, -3. Say that again? Oh, that is, you're right. 3, comma, -4. That's for the question that we did earlier. Get that out of the way. That fooled me. 3, -4. Thanks for saying that. And then all you do is decimally go up 3.74, down 3, blah, 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 blah. 1, 2, 3.74, right? Because I went 4 down, correct. And then 1, 2, 3.74, that's all you do. 3.74 a little on that side. 1, 2, 3, 4, 3.74 there. The only thing you probably can't do now is input, say it. You got decimals for those endpoints now, so it's kind of hard to plug those in and check them. All right, so you just kind of move on. All right, just being honest on that. Okay, I'll stop the video and then let you do your thing.